Welcome back to the reaction zone. In today's lesson, we will look at how to solve the problem on the board making use of the ideal gas equation. And the question is as follows. What is the pressure in atmospheres in a 50-liter gas cylinder that contains 16 grams of oxygen and 4 grams of helium at 27 degrees Celsius? To solve this problem, first of all, itemize the parameters of information from the question. We are told to find the pressure that we don't know. We are given the volume to be 50 liters. We are given temperature to be 27 degrees Celsius. To solve a question involving use of the ideal gas equation, temperature must be in degrees Kelvin. So to convert that, we have to add 273 to this, and this will give us 300 Kelvin. Now we're given the mass of oxygen gas to be 16 grams, and we are also given the mass of helium to be 4 grams. We're looking for the pressure in the atmosphere, so the value of the molar gas constant, R, is going to be 0.0821. Recall that the ideal gas equation is P is equal to nRT over V. But when you look at this question, we are not given the number of moles. Instead, we are given the mass of 2 gases. So it means that what we have to do to solve this problem is to find the number of moles of each of these gases and find their sum that will represent the total number of moles. Only then can we now find the pressure in atmospheres. So we'll start by saying the number of moles for oxygen is simply the mass of oxygen over the molar mass. And this is equal to 16, which is the mass of oxygen, over the molar mass of oxygen, which is 16 times 2, which is 32. 16 divided by 32 will give us a value of 0.5 moles. The next thing is to find the number of moles of helium. The mass of helium given is 4. The molar mass of helium is also 4. So 4 divided by 4 gives us 1 mole. What this means is that the total number of moles, N total, will now be equal to 0.5 plus 1, which is 1.05 moles. So the value of pressure that we're looking for will now become N total times molar gas constant times T over the volume. So pressure in this case will become 1.05 times 0.0821 times temperature in Kelvin, which is 300, over the volume, which is 50 liters. So the pressure in atmosphere is going to be 0.74 atmospheres. Thank you for viewing, and see you in the next lesson.